Chapter 1 Set Lecture 5. So what we are going to learn today is subset. So what is subset? A set is said to be subset of a set B if and every element of A is also an element of B. Okay, so this is the sign of subset. What is written in this definition is, suppose A has 1, 2, 3 and B has 1, 2, 3, 4, 5. So A is already inside B. The subset means this, that A, all the elements of A is present inside B. That's why A is subset of B. Get my point, guys? Okay, coming to our next point, which is listed here, is A is subset of B if A belongs to A, means A came in B and A is also came in B. So then we can say A is subset of B. Suppose we got some conditions when A is inside B and B is inside A. A is 1, 2, 3 and B is 1, 2, 3. So A is a subset of B and B is a subset of A. So that means A and B are equal. If and only if. Here this symbol means if and only if. Okay, so we all know that what is set right now. Now we will continue with the third star point, second star point, which says that A is a subset of itself. Means A is a subset of itself. Is it true? Suppose A is 1, 2 and another A is 1, 2. So A is inside of this element, this another set, so A is subset of itself. A is a subset of itself. Is phi is subset of every element? You know that phi means empty set. So every set has this parenthesis, and this parenthesis itself signifies that it is an empty set. So phi is subset of every element, every set. Phi is subset of every set. So you will have to keep in mind these 3 points which is noted here. A is subset of B and B is subset of A only and only if A is equals to B, and A is subset of itself and phi is subset of every set. Now coming to some special name of the set, which is proper subset of proper subset. So the proper set we can only say if A belongs to B and A and B are not equal, then A is called proper set of B and B is called superset of A. So these two terms you will have to keep in mind, that what is superset and what is proper subset. Okay, superset means a set which is superior, means a larger set. Suppose B is A, B, C, D and E, and another set A is C, D. So from here you can see that A, all the elements of A is present in set B, so A is subset of B. Since A and B are not equal, so A is proper set of B and B is superset of A. B is superset and A is proper set, proper subset. So any set to be proper set must not be equal to its superior set, means it should be lesser than its primer one. Okay, so in this I just wrote this example. A is 1, 2, 3 and B is 1, 2, 3, 4. So A is subset of B, and B and A are not equal. A not equal to B. So combining these two conditions, we can only say that A is super subset of B. Okay, what is singleton set? If any set contains only one element, then we can call that set as singleton set. If A has only one element, then we call it as singleton set. Got my point? Okay, now I will explain you subset of real numbers. So I will briefly tell you all the symbols name here. N means natural number. N means natural number, and what are natural number? Natural numbers are 1, 2, 3, 4, 5, to infinite, positive infinity. Z is actually the integers. Integers. What are integers? From negative infinity to -2, -1, 0, 1, 2, 3, or up to positive infinity. This is the set of integer. Q is a rational number. Rational numbers are all the fractions. 1 by 3, 9 by 8, minus 9 by 4, 0, and dot etc. All the 1, 2, 3, -1, -2, etc. Everything is rational number. We're coming to the real number. Is the real numbers. So real numbers is a combination of all this. Real number can be rational number, can be natural number, can be whole number, can be fractional. It can be rational number also. I will have to tell you about this earlier. Okay, telling you about T. T is irrational number. Irrational numbers which can't be expressed in the form of P by Q form. There are so many irrational numbers. Any square root, cube root of 5 by 8 to the power 9, 1 by 9th kind of irrational numbers. So from here you got the point that natural number is already present in this integer. You can look it from here. Okay, so you see the natural number starts with 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 is also present in here up to infinity. So the whole natural number is a subset of what? It's a subset of integer. That's why they wrote z is n is a subset of z. N is present in z. We're coming to our second part. Is z is part of a z is subset of q? Let's see. Since rational numbers are all can be written in the form of p by q, so this whole, I will change color to emphasize some meaning here. The whole integer is present in where? Is present in rational number. That's why z is a q is a rational number. Q is a z is a subset of all those two. Now coming to our third meaning here, third question, third part, third slide, anything you can say. Okay, they are saying is Q is a subset of real number. Yes, of course. Real numbers are what? Real numbers have everything, rational, irrational, everything. So all the rational numbers is a subset of what? Is a subset of a real number. Okay, so real number combines everything out there. Also, we can say that irrational number is a subset of real number. We see that irrational number, whole irrational number is a subset of where? Is a subset of real number is some part of. So we say that they twos are subsets, but natural number is not subset of irrational number. You know the natural number can be written in the form of p by q form. So they are obviously irrational number, and they are no, irrational number, and natural number is a rational number. So natural number is not a subset of irrational number. So I think I tried my level best to explain you this, the whole scenario which is going on here between all the numbers. Okay, now I will have to explain you the intervals of subsets of R. I will first explain you the closed interval. About closed interval is this one. If I write two numbers here, what it means? It means that between A and B you will have to take everything, and you will have to take also A and B as your answer. So it actually means A is less than equals to and less than equals to. So we are taking A as well as B, and also all the numbers between A and B. A, I will write some statement here. We are taking A as well as B, and all the numbers between A and, so we are taking actually three things, everything, A and B and all the numbers between them. In open interval there are different there are actually three types of open interval. Open interval, okay, so open interval sounds like a parenthesis. These are square brackets, square brackets, 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 so square brackets, and they are parentheses. Parenthesis, maybe I don't know what's the spelling right here. If I put two numbers A here, A and B, so and mark A and B on number line, so you will only take all the numbers between, only take all the numbers between A and B. You will not take A, not take B. So how to write this as a formula? A is less than X, X is less than B. So just less than, no equals to sign here. You don't have to consider A and B as your prime answer. In open interval, if I put a close sign here in A and put B here and parenthesis here, so what it means, it may be open at A, open at B and close at A. So at the side of close you can put is equals to sign, and in the side of B you will not take B as your answer. Another type is you put parenthesis on A side and put square bracket on B side. So what it means, it means you will not take A at this time and you will take B as your answer. So these are the four means. You will have open interval here, open interval here and closed interval here. You will have open interval and closed interval here, means you will not take B, you will take A, you will not take A, you will take B. And to explain this, what I will draw this, that you will neither take A nor take B, you can take only the numbers between these two. Okay, not take A, not take B. In this case, you will take A, you will take B, and you will also take all the numbers between A and B. Okay, so I will explain you the intervals of subsets of R. Coming to our next topic, that is power set. Power set. The collection of all sets of subsets is called power set. Collection of all subsets of a set means you will have to make all subset of A, all subsets, and then unka collection. Then finally you will get the collection of all set of A. Okay, so I will explain this as, suppose A has two elements. So how many subsets you can make? You can make one, you can make two, so we can make only two subsets of this set A. But forget the point that I explained you earlier, that every set is a subset of itself and phi is a subset of every set. So we can make two more subsets using these two properties. A is a subset of itself means we can also make a subset of A itself, and phi is a subset of itself. So that's how we make four subsets of set. If we collect these sets in A in another set, then we say that it is a power set of A. So subset, collection of all subsets of a set is called power set of A. And if you just want to know how many subsets of a subset can we make, then you can find it as number of elements in power set. Number of elements in power set is 2 raised to power n. N is the number of elements in a set. Okay, n is the number of element in set. So in this case we have two elements in this set A, so number of element in power set of A is equals to 2 raised to 2, which is 4. So that's why we get actually 4 element in the power set of. Got my point? Coming to universal set. Universal set may be considered as a superior set. Superior set means all the elements are taken from this set only. Suppose I tell you the subs set 1, 2, 3, and another set A, B, C, and another set apple, mango. So we will have to make a such set, or consider a universal set from where all these elements came from. So I will make U as maybe 1, 2, 3, 4, 5, or much greater than this. I will take A, B, C, D, dot, 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 dot. I will take apple, mango, banana, etc. dot, dot, dot. So universal set is a superior set from where all the other sets are taken from, or can be considered as that they must be came from that set, such that A is a subset of universal set, B is a subset of universal set, C is a subset of universal set. So all the other sets, if all the other sets can be considered as a subset of a universal set from where all the elements can be taken, So that set is known as universal set, and we generally denote universal set by capital U. We will try to solve some questions on behalf of we have learned so far. Okay. Consider the set phi a comma b a 1 comma 3 b 159 c 1 3 5 7 and 9. Insert symbols of subset and non-subset. Okay, so here this symbol means subset of, and this symbol means not a subset of. Okay, so phi is a subset of B. As you know, there's a phi is a subset of every set. Okay, so phi is a subset of every set. So we say that yes, phi is a subset of B. Phi is present in B, that's why phi is a subset of B. Okay, coming to this question, that is A is a subset of B. So for A to be subset of B, all the elements of A must be contained in the B set. So we see that 1 is contained in B, but 3 is not contained in B. So A is not a subset of B. Can we say that A is a subset of C? For A to be subset of C, all the elements of A must be contained in C. Yes sir, 1 is present in this set C. 3 is present in that set C. All the elements of A is present in set C. So if we say that A is a subset of C, can we say that B is a subset of C? Let's see. 1 is present in C, 5 is present in C, 9 is present in C. So we say that B is subset of C. We solve our first question of this topic. Coming to our next example, this is example number 1. Coming to second example, so they say A is a subset of, A is a set of all vowels A, E, I, O, U. B is a subset of A, B, C, D. They are saying is A is a subset of B. I told you that for A to be subset of B, all the elements of A must be present in B. So we will map right now that which element is present in A and B. Okay, so A is present in both of these, and none of the other element is present here. So we simply try to give justification over here that. So what is the answer of this question? The answer of this question is no. A is not a subset of B. No, they are saying why. So we will answer them why. A is not a subset of B because not all the elements of A is present in B. Okay, is B is a subset of A? B is also not a subset of B. We'll again write B is also not a subset of A. Why? Because all the elements of B are not present in the set A. Because all the elements of B is not present in A. Coming to our next example, let A, B, C are three set and A belongs to B and C belongs to A. It is true that A belongs to C. Let's see that A is example 1, 2, 3. that A belongs to B. A belongs to B means what? A belongs to B means A must be contained in B. Okay, so we consider B as 1, 2, 3, comma 4, 5. So A belongs to B. And is B is a subset of C. Okay, B is a subset of C means, okay, we consider C such that 1, 2, 3, 4, 5, 6. So this is C. So we fulfill the criteria that all the elements of B must be contained in C. So they have a question here right now is it true that A belongs to A is a subset of C also? So going to give their answer as A is a subset of C. For A to be subset of C, all the elements of A is will not be present in here. So we say that no. The reason is in front of you that 1, 2, 3 are the elements of A and 1, 2, 3 are not the elements present in C. Okay, so reason is A has element 1, 2 and 3, but set C do not have these elements. That's all for today, guys. See you very soon on our next